Good afternoon, ladies and gentlemen, welcome to another Unity 3D tutorial. We're going to take it quite slow today because this is something that everybody kind of wants to learn, mainly because the games that they want to create are kind of Dota-ish, League-ish, Smite-ish, want to do that type of stuff, even though Smite doesn't really apply to this one. This is the click to move function, guys. Now, pretty sure I've gotten a request for this so far, so I'm going to fulfill that request, and also the request to continue making videos, because somebody said keep making instead of just streaming. It's all good. I believe that that's the right thing to do. But anyway, what we're going to try and achieve right now is this thing right here. Now, I've got an animated character here, so I'm going to apply it not to an animated character, and then I'll teach you guys how to do the animations, possibly in one more video, because I kind of want to make these short enough so people can skip parts that they already know and stuff like that. So basically that's it. So you just right click somewhere, right click here, and your character will move to that position. Now, the difference between this and your regular click to move tutorial is that this is actually properly networked, as in this network is flawless. It's basically League of Legends duplicate. The only thing that is missing is what would you call it, pathfinding, right? So if I was to try and go through this, it will try and go through that, unfortunately, which is the only thing I don't really like about it. But other than that, it's pretty cool. Now, the first thing we want to do is to create two scripts. Now, the reason why we need two scripts is because it is over a network. Now, we want a script where people can receive the movement, and we want a script where people can send the movement. Now, of course, if you're sending stuff like movement, you don't want anybody else to affect that. So the only person who should see the send movement script is yourself. So the first thing we're going to do is go ahead and create our game object. Won't be a second for this one. Basically, I'm just going to grab a empty no, we'll go 3. We'll just make a nice let's go capsule. Sweet, okay, capsule, and we'll chuck that in the very center of the map, which will just go 0, 0, 0, awesome. That helps us out a lot. And then for the capsule, we're going to create another empty object, and there's a reason behind this, guys. There's a reason. It's basically so that we have our graphics separate to everything else. Now, oh, actually no, a capsule would not be a good idea for this. So we're going to replace that capsule actually with a cube. Now, the reason is because we also want rotation so that they actually face the direction that they're going, and we also want them to slowly slurp into that direction. If you don't know what slurping is, it will be explained soon, guys, but a cube is the only thing we can actually test this out on properly. So basically we'll just set that to 0, 0, 0, and then we'll get the game object, which is 0, 0, 0 as well. We'll call this game object player test, which is good, and then we chuck the cube onto that player test, and then we're going to move the cube up half a notch, which is 0.5 on the y-axis. And the reason for this is basically because, as you can see, he's on the very top now. So if we do go to player test, however, what we can do, which it is at the bottom, that's good. What we can do right now is add something called a Nav Mesh Component, right? If we go Nav Mesh Agent, a Nav Mesh Agent, right? And the reason why we're adding this, we'll just leave all the settings as default, is because basically the Nav Mesh Agent allows us to move on something called the Navigation Mesh. Now, the Navigation Mesh is what you see right here, which is this blue thing, right? Basically, any place on this map that is blue, the player can be in at that time, right? So, let's say you wanted to try and walk onto this hill. Well, you can't walk on this hill. It is literally impossible for this object to get on that hill now that it has a Nav Mesh Agent component, and there's a navigation mesh on here. Now, if you want to know how to do a navigation mesh and what it does, I would recommend that you listen in on this little tutorial type thing. Basically, I'm going to just explain it for now, but I'll do a separate tutorial on it later. Nav Mesh Component, you can pretty much bake with a whole bunch of settings. So if we go to Navigation and Bake, and if you do not have this navigation window in the top right, you can go into Window, and then you can go down to, it should be down here, Navigation, okay? That's how you get this window here, this little tab here. And anyway, open this tab, and basically if you just click on that bake icon and then click bake, it's going to make sure that every single flat surface that you have on this map will turn into this blue, and it's basically a mesh that people can walk on, right? So this is kind of veering away from the whole it's not really involved in the click to move, although it's quite important for you guys who want to do click to move that doesn't require any hills and stuff like that. The only problem with this tutorial is that you can only click to move on a flat surface. Now, as far as I know, League is quite flat. It's got a little bit of hills and bumps and stuff like that, but the pathfinding helps sort how that stuff works. So basically, once you've got this navigation mesh, and it's also a Nav Mesh agent on there, we'll just minimize that so that we have room. We want to add 2 scripts, right? And I've already pre-made these scripts. Now, in order to make scripts, you just need to right-click, create, and then go C# script. But since I've already made them, they're empty, so I'm just going to drag them onto my player test, right? There we go, and send info and receive movement. Okay, so basically, this is a good one right here. Yep, awesome. Okay, so we pretty much got that. So, if you have already networked, then this is going to be incredibly easy for you. If you have not, you're going to need to go back to one of my old tutorials where I teach you how to network a game. You want to set up your network so that you have pretty much the whole spawning people and stuff. And yeah, that's pretty much it. But anyway, so we have 2. We have one called send info and one called receive movement. Now, those are just the names I chose. You can choose any names you guys want, guys. It's pretty much just send info is pretty self-explanatory and receive movement is pretty self-explanatory. That's the only reason I chose those 2. The first one we're going to work on is receive movement, because we can't send info to nothing. We need to send info to something, right? But so let's say we have received movement. Now we're going to create a few variables at the very top of the class here, right? We are going to create, the first one I believe is called vector3, right? And I'm going to call it new position, okay? Basically, a vector3 is a position, right? It only holds X, Y, and Z of a place in your map in 3D space, right? So the vector3 of new position is going to be, in the future, it's going to be the position that I want the player to travel to, right? The position that the player has clicked and the player wants that this game object to travel to, right? So I hope I'm explaining myself quite well, because hopefully I'm getting actually better at this. The next thing we want is a speed, right? So we're going to go public float speed, right? Basically, that's just a number that's going to give how fast our character is going to travel. And the next thing we're going to want is public float walk range, okay? We need a range, capital R. We need a range, right? We need a range that the player will spot. So let's say the new position is a centimeter in front of our character. Would our character even bother to walk there? Probably not. Not in a game like this, right? But if it's, let's say, a meter away, oh yeah, maybe he'd walk there, because there's actually a significant change in that. So the walk range is basically going to hold how far the character will judge whether or not it needs to move to a certain place, right? Because let's say people were moving centimeter at a time, you get a whole bunch, you could always get a whole bunch of unnecessary clicks and stuff like that. It's just unnecessary messages being sent through your network, and that's going to slow your game down, not significantly, but to an extent, right? So basically, once we got those 3, which are the only kind of 3 variables we need one more variable, which is going to be public game object, right? And the game object is going to be our graphics, and this is basically going to show our rotation of the character, right? So once all that is done, we're going to go start. Now at start, we want our new position, right? Our new position to be our current transform position, right? The place that we spawned, right? Which means this transform dot position, right? So basically, our new position, right, which is the place where we want to go, the player wants to go, is going to by default be where the player already is, right? And the reason for this is so that when the player spawns in, he's not walking somewhere random, okay? He is staying in the exact same spot that he started, right? So that's pretty much it, guys. For the start function, now we're going to go into update. Now update's going to be a... Okay, update is going to be a bit of a good one. Now, basically, update is going to control the movement, okay? So the only reason we would move is if the distance between us and the walk range, right, is greater than a certain amount, right? So we are going to go if the distance... Oh, what fixed? What did I do here? If the vector3, right, dot distance, right, between, and we got exhibit A, which is our new position, right? Our new position and our current position, which is this dot transform dot position. If the distance between those two is greater than the walk range, which we're going to set later, then, right? So basically, vector3.distance is the distance between two objects, or two positions, not two objects, I should say. You can get the positions from the objects, but basically the new position is where we want to go, and this is where we currently are, right? So if the distance between where we want to go and we currently are is greater than our walk range, which we kind of agreed on to be about, I'm guessing like 0.5 meter would be pretty good. But going in something like centimeters, I mean, you can't calculate that in 3D space, but I'm going off on a tangent here. Sorry, guys. I'm just actually very excited for this because I'm starting to love these tutorials again. Basically, so if that is all that, then that means we want to move our transform position, right? So transform dot position. Just to be safe, we'll go this dot transform position. And oh, no, what am I doing? Here we go. We want to make sure that this transform position is going vector3 dot move towards, oh, dot move towards, vector3 dot move towards, and what have we got here? We got current, target, and max distance delta. Yes, okay, so within this function, vector3.moveTowards, we need 3. Okay, so we need our current position, which is this dot transform dot position, right? Basically, that's it. And then we need our next one, which is new position, right? That's our next position. And then finally, we need something that says here, right here, float max distance delta. That is basically the speed at which we want to go, right? So instead of any max distance delta, does not explain it in the slightest, but we're going to go speed, right? Times, which is the little asterisk, oh, speed, yep, times, right, time dot delta time, okay, and then we'll shut that off with that thingy. Basically, our transform position, assuming that the distance is greater than the walk range, our transform position is going to start moving towards using the vector3.moveTowards function from our current position to our new position, right, at this speed. Now the times.delta time is not something you guys really need to know. All it does is really cut down the amount of numbers that we need to use. So instead of using 100,000 for our speed or something like that, we'd be using something like 1 for our speed. Sorry, not 100,000, but just ignore it for now, it's not that important. So pretty much that's going to control us moving towards character. Now at this point, usually I would test it, but not this time, guys, because I'm starting to get to that programming point where I can actually write down a full script, then test it, then find bugs, rather than writing out the script slowly and testing it frequently. Okay, so next is basically we want to get we want to create something called a quaternion. Right, quaternions are pretty cool because they're vector3 but for rotation, so they're the XYZ rotation, right? So we're going to basically call it vector3 trans, which is going to be short for transform, and then rot, right, for short for rotation. And basically we are going to create our own rotation out of nothing, and that's going to hold which direction we actually want to look at, right? So the way we do this is go to use the quaternion function. Oh my god. Oh wait, did I already hit it? Oh, quaternion, there we go. So quaternion function, it's dot look rotation, right? And basically we want to get the forward's position, right? And the forward's position is where we want to go, which is new position, right? Minus our current position, this dot transform dot position, right? And basically that's basically creating a line, right, between our new position and our old position, which we're going to travel, which we are going to start looking at. It's not creating a line, sorry, it's creating a direction, right? Using those two. So once we got this, we want to get vector 3 dot upwards. Yes, so we're going to go vector 3 dot up right there, right? That's pretty cool. And then we're going to shut that one off right there. So that's right there. That's pretty much this whole thing. We've just created a random rotation out of nothing. It doesn't apply to anything yet. What we want to do now is apply it to our object, right? Well, we don't want to apply it to our object, sorry. We want to apply it to our graphics, right? So instead of going something like the transform rotation, right, moving, we are going to grab the graphics rotation. Remember here we got our graphics object, because we don't actually want our character to move around. We want our graphics to move around and our character to stay in the exact same position. And there's a reason for this. I won't explain it in this episode because there's other intricate stuff that you'd probably need to go over before getting to that point where it actually starts affecting it. But for now, I've kind of thought ahead, and it's going to work like this, basically. So again, you do not need to do it this way. This is just the way that I decided to do it. If you're only here for the networking, that's coming up soon, guys, don't worry. But there's one more step that we want to do, and that's basically slurping. Now, instead of our character, and I noticed this, in League of Legends, it's a lot faster. So instead of our character just looking at the direction that we're going, we want it to turn to the direction that it's going, right? So it has a nice smooth movement feel to it. Sorry. So basically, we are going to change the transform rotation of the graphics, right? So we got to go graphics dot transform dot rotation, right? There we go. Is equal to, and we go quaternion dot slurp, right? And between that, we want to slurp it from our current transform position. So we go graphics dot transform dot position. Rotation. Sorry, dot rotation. There we go. And we want to slurp that into. We want to slurp that to our new rotation, which is called transrot. Transrot, which we created right here. This is our quaternion right here. Transrot. Sorry guys, I'm just taking my time with this one. Transrot, which is a rotation, and we want to do that at the speed of. I'm just going to go 0.2. We need to make a float out of that, so we chuck an F in the end. Basically, that's how a slurp function works. You change your graphics rotation to this. Now, I have a feeling that these two are the wrong way round. Benefit of the doubt. Why not? We'll just change these for a second here, and we go transrot on this side because it's from trans. Okay, yep, that would have to do for now. So basically that's all we need, right? That's all we need for that part. Now there's only one more part of this, okay? We want to create something called an RPC, which is a remote procedural call. And Photon has their own, they call it PUN, which is Photon Unity Networking. So basically if you go square parentheses or whatever they call them, and you go PUN RPC, right? Capitals, and then underneath it you want to create your own function, right? Basically this is something that can be called through anyone's computer. Anyone can call this RPC. So this is the RPC that we want to send a position to, right? But we want everybody to be able to receive this. So basically the RPC is going to be received on everyone else's computer, and it's going to run this function, which we are going to call received movement. Received move. Actually, we'll just call it received move, okay? And within this function, right, we're going to add some more brackets here. And we are going to want a vector 3, right? Now, if you're lost in this position and wondering what the fraggity frack is going on, we call this move. Pause just for a second. Okay, move position right there. Beautiful. Okay, we've just created our function here. Basically, this is the way this script is going to receive the place we want to go. Now, because we don't want anybody else to send it, right? We want everyone to receive it, but we don't want anybody to send it. We don't want anybody to send where our character is going to go. We only want to control our character. We make sure that we have two separate scripts. One is active on your computer, which is the send info script, which we have right here, and the other is not active on your is active on your computer, but is also active on everybody else's computers. Now this is kind of important, kind of not important, but it depends on how you want your game to work, of course. If you want your characters to be controlled by other people for some ability reason, then be my guest, it's all good. Basically, receive movement by everybody, and the vector 3.move position is basically whenever this receive movement thing is called, it needs to send a vector 3 through the network as well. So if we go into the child of that function, I have a feeling this is getting very long. 19, nearly 20 minutes. That's all good actually. That's not too bad. So here we want to go pretty easy. New position, right? is equal to move position. And that's it. That's literally the networking, because we've sussed everything out in the rest of this video, right? We've got our new position here, right? A new position here. And if the new position changes, then that means it will call this function right here. Now, all we need to do is change the new position in order to get that received movement, right? Now, we're going to go into send info, right? Because this is clickable. We'll save that first, of course. We don't want to lose it. Send info, right? So if we do go into send info, we are not going to need too much, but this is basically how to get the position that you've clicked to, right? So within the update function, we are going to create a boolean, which is a true or false statement. Basically, we're going to call it right mouse button, okay? For the right mouse button, we want to make sure that it is the input dot get mouse down. Oh shit. Yeah, get mouse button down right there. And then in brackets we want to put 0 because we want the 0 position for the mouse button. So, oh wait, hang on. Actually, I think it's 1. Yeah, I think it's 1. Okay, so pretty much all this is numbers. So you got 0, 1, and 2, right? So 2 is the middle mouse button, 0 is left click, and 1 is right click. So we want 1. If you want left click, then you go 0 and stuff like that. But basically, once that's done, we want to create a raycast upon clicking this right mouse button. So we want to go if right mouse button is clicked, or we can just put RMB and it automatically does it to if right mouse button is true. Within that, we want to, so every time they click it, we are going to get the position of where they clicked, right? And the way we do that is go something called, oh hang on, just put some spaces in here. Raycast hit, right? And we'll call that hit. Okay, it's pretty easy. And then we want to take that ray, we'll call it ray, right? And basically that ray is going to equal, this is quite important, camera dot main, which is the camera that you can currently see, dot screen point to ray right there, screen point to ray. And that's basically getting a position on the screen. But which position? Well, we need to get the input mouse position, right? So we need to find where the mouse is on the screen, send a raycast through the screen to the object that it hits from the mouse, and then that sends the message back to us, pretty much telling us where it is, right? So input mouse position, there we go. And we can cut that off like that. So that's pretty easy, guys. And the next thing is we want to check if we hit anything with our raycast, right? Now, if you do not know what a raycast is, it's basically a beam that interacts with collidable objects or objects in general. It doesn't really matter. So basically, whatever you click currently, it's going to go, oh, okay, it's going to send back the object that you clicked, first of all, and not much else. It's not that important. But yeah, oh, what is that important? I don't know what I'm talking about now. It's all good. This is the final steps, guys, not too long to go now. And basically, if, this is how we find out, if physics dot raycast, and then we want to get our ray, right? And then we want to make sure that is the ray out hit. I don't know what the out means, to be perfectly honest. I'll just say it means the raycast going out. I'm not too sure. Basically, and then we go and, oh, we don't need that one. We need, so if our raycast hits sorry, if our raycast hits something, right, and we also want to make sure that what you're clicking is actually the ground and not a player, right? So there's going to be a few things in your game that you're going to want to click. There's going to be the ground, there's going to be players, and then there's going to be objects like minions, I guess, is a good, creeps. A good thing is probably objects you can pick up and stuff like that. And we all want to gather what these are. So this send info thing is actually going to be more than just movement in the long run. But for now, it's just going to be for movement because that's all we really care about at this current point. So basically, we want to check what he's clicked, right? So for this function, for this if statement specifically, it's going to be the ground. So we want to go hit dot transform dot tag, right? Equals, and then we want to come up with a name for the tag we've created in game, right? For mine, it's called ground. So I've actually labeled my terrain ground, right? basically, once that is done, that's pretty much it for the whole function thing. There's one more. Now this is incredibly important. This is basically linking the two scripts together, right? For this one, we want to go this, right? Dot get component. Yep. We want to get the photon view. Photon view. There you are. And basically, we want to call an RPC. Okay. The RPC we want to call is called receive movement. Now I'll explain what this is for. So basically in brackets we've got to go received move. Oh wait, was it capital? It was capital. Hang on, we're going to check just to make sure. In our receive movement script, received move I before E, except after C. Received move. Oh wait, received it. Received it. Yes, with a D, not received move. Received move, and we want to send it to all photon targets. Photon targets dot all. Yep. And finally, object parameters. Dot point. I believe. Okay. Basically, the script is going here. Now, the only way to access our network or other networked objects is through something called a photon view, right? So our characters in turn going to need a photon view along with the navigation mesh agent and all that type of stuff. We're actually going to save this right now. And I'm going to explain this very, very well because you guys really need to understand. So we have our player right here, right? Player test. Now, the one thing we need as a component on is something called a photon view. In order for it to be a networked game object, we need a photon view, and that photon view needs to observe the received movement script, okay? So if we drag and drop that in like that, that's awesome, done, okay? Basically, send info is going to send stuff out using this script, right? And basically this script is getting the photon view component, right? Going out into the network, coming back into the photon view component, trying to find this RPC or remote procedural call right here called receive move. Once it has found that, it's going to go, okay, we'll apply a receive move to all our photon targets, which means every single person amongst our network that, amongst our game that we're currently in, is going to receive that that call for receive move. We need receive move. Okay, so. Oh, hang on a moment. Receive move, we need a vector 3 position, which we called move pos, right? Oh, so well, we need a vector 3 to come along with that receive move. How are we ever going to get it? Well, we'll send this one right here, right? The hit dot point. Now, there's a lot of hit dot everything. Like we've got hit dot transform right here, dot tag. Hit dot point is basically the vector 3 position of the exact thing that you hit with your mouse, right? So when you right click, right? Right mouse button right here, the raycasters get sent, and assuming that you've hit anything in the scene, that hit dot point will create a vector 3 position for that place right there. So you are sending hit dot point across a network, they are receiving it, then they start performing this script, which is basically going to make everything come to life, and it could be very cool. So let's go ahead and start the testing, because I have a feeling something is missing from this character and stuff like that. First things first as well, actually, we got to go chuck him in our resources folder. Because he is a networked game object, we'll delete him from the scene. Oh, actually, no, we can't do that. Oh, yes, we can. Yes, we can. Okay, now we have a few things here. The graphics. I want to chuck the cube as the graphics right there, because it is the graphics. Also, the walk range, we're going to put as 0.5 just for now, which is about, you know, half a meter, even though it's 3D space, it doesn't really count. And our speed. I'll check what I used for my other character. Speed was 5. Okay, we'll go speed 5. It's pretty much it. Actually, we'll go speed 3, because then it just takes longer, and that's quite good. Okay, so now we're going to save our scene right there. And basically, player test with capitals is the one we want to instantiate. So, if you haven't already created a network manager, I would suggest that you go ahead and create one, because right now I'm going to go ahead and make sure warrior and make sure this guy. Okay, we'll change it here. Cube. My hero will equal player test. Connection, yes, all that good stuff is there. That's great. Okay, cool, awesome. Okie doke, I'm going to continue some more on this in another tutorial, but for now at least you guys got something that's working, because if we do click play, and I've networked everything, again, if you have not networked everything, I highly recommend you go back and watch another tutorial of how to network this game, because basically I use the exact same networking through every game I've ever made. The only thing that's different right now is the map, which I think is looking incredibly swanky. And before I leave this video after testing it out, I really want you guys to know that I just started streaming, and I've just clicked this now because I know you guys are getting bored as hell. Finding match, now playing, and oh my god, what have we done? What have we done? Movement.enabled. We'll cancel that out, eh? There we go. Sorry. I'm so sorry. Oh, that was so climatic, and then it just dropped. But yes, basically oh shit, wrong character. I basically started streaming on Twitch, basically of me creating this map, and I'm still creating the map as we speak. There we go, guys, look at that, holy Christ, that looks cool. Okay, so basically, we right click, and our character, if you can see that it is slurping, it's incredibly fast for the slurping. I can turn it down a bit just to show you guys how the slurping actually works. Basic 0.2, we'll go 0, we'll just go 1, actually, 1.2. Let's just try and be complicated with that. And if we click our play and we play as the cube, we come along and wow, that is way too. No, you can't. Sorry. Oh my goodness. Oh, I'm so bad. 0.7. There we go. That's better. Oh man, I'm just screwing around right now. So yeah, there we go, that's slower and a bit more realistic and stuff like that. That's actually really cool, guys. So thank you very much for watching this tutorial. I hope this helps you, and I hope this really brings your game to life, because if you are creating games, another thing I would actually like to do is, you guys feel free to submit like screenshots or whatever, because I really want to start showing your stuff off to other people, because it's quite cool that you can actually create a development team online now. It's so easy. If you just find people who have similar interests, who have similar wants and needs, who have skills that you don't have, and then you guys can all work together as a team. It's one of the greatest feelings in the fucking world, to find people that, you know, actually think similar to you. So I really hope you guys enjoy this tutorial right here. Yeah, basically, if you run out of networking, just go check out other videos and stuff like that. I love you guys all, because seriously, this is starting to get quite big out there, in my opinion, because I've never had 440, however many people I currently got now subscribing and watching stuff like this. It's quite cool. And I hope you guys have a great day. Thank you very much. I really don't know what else to say. I'll end it on a positive note, is that I'm going to start streaming right now, because I'm really enjoying this stuff, and I haven't had a lot of free time, so I apologize for the very lack of uploads and stuff like that. There's probably the moment where nobody's listening because the video is about to end, and nobody cares, they've already got what they need. So, see you guys later, have a great day, and good luck with your game.